Section 3.9 is about the inverse trig functions. And in this lecture note part, I've given you some graph examples, and I want to just point out a couple of things. Like, this is the notation for inverse sine or inverse cosine, all of them with the -1 up there. It's really not a -1, it's an inverse sine. And it's like you took, here's the sine curve, and sine's doing this except a perfect curve, and it's like you flipped it on its side because x and y trade places, and when they trade places, the range that you used to have with sine, and I shouldn't have erased that, but when you do this with sine, we know it goes between 1 and -1. That's the range. Well, when we switch it and we have the inverse, then it can only go between 1 and -1, and its range here goes from -pi/2 to +pi/2. So that's for inverse sine. For cosine, what we find is that it goes from 0 to pi. And so you may have to look back at these range restrictions when you start working the problem. So look at that, and then let's see, let's get down here. Then you're going to get the derivative rules for all of them, and I did just an example for sine, inverse sine. So the inverse sine formula is right here when you're taking inverse sine of u, and it's 1 over the square root of 1 minus whatever u is squared times the derivative of u. So you might think that you could actually think of the formula as u prime over the square root of 1 minus u squared. Okay, so when we have this, u is x squared, so 1 over the square root of 1 minus x squared squared times the derivative of that. Well, the derivative of that is 2x. So if we were looking at it in this way, we would have put 2x on top and square root of 1 minus x to the 4th. So you're really just filling in the formulas for those, just being careful. And here's the rest of them. Here's inverse tan, inverse secant, and here they all are listed. And these cofunctions, and they're kind of color-coded there, there, and there. They're the same formulas, but one of them has a negative sign, SIGN. So that's negative there, there, and there. So if you were having to memorize them, that would be a good strategy. All right, let's look at the problems. Okay, these are all worked. I'm just going through them. And here's this chart that I put up at the top. You have that actually on your on one of your sheets that we used for the test, but I've put it up here because it's good reference for these questions. Find the exact value inverse tan of negative square root of 3, and what that's saying is which angle has a tan of negative square root of 3, and it has to fit in the parameters that we just looked at. Tan has to fall between -pi/2 and pi/2, so that's going here this way. And so you could look up here, and in tan, where is negative square root of 3? Well, there's one of them, and there's one of them. Well, 120 is over in this quadrant, so that doesn't work. 300 is over here, but we have to think of it as -pi/2 down here. So 300 would be a 60-degree reference angle, so that would be -60 there. That's where we get the -pi/3. And again, that was 300 degrees was what we found here. And how far is that from here? This is 360. When you want reference angles, and you got to remember that from trig, that's 60 degrees this way, and that would be a -pi/3. So that's how we would come up with that particular answer. Same way for this one, inverse sine negative 1 over square root of 2. Well, those aren't going to be listed that way in your chart, so you would want to rationalize it, and you get negative square root of 2 over 2. So you go up here, and we were talking about sine, and so we are here and here. Now, and we are still have the parameters negative pi over 2 to pi over 2, so we're still like this. And so 315, 225 is going to be over here, so that doesn't work. So the 315 is here. The reference for that, it's 45 degrees up to there, so we're talking about 45, so we would have to call it a negative pi over 4. So that's the thinking for those. I'll let you just look through the lecture notes for that cosine one and the cosecant one. Same thing for this one. Now we get down to number 6. Find the value of sine of inverse cosine square root of 2 over 2. Well, inverse cosine square root of 2 over 2 gives you pi over 4. We should know that from trig that the angle 45 degrees or pi over 4 has a cosine of that. So then this goes in for the sine part. So now the sine of pi over 4 is the square root of 2 over 2. It happened to be the same thing because for that particular angle, sine and cosine are the same thing. Same thing here, tan of inverse sine. So inverse sine of that is again pi over 4. Tan of pi over 4 is 1. Number 8 is a limit question. Find the limit as x approaches 2 from the left, and then you have inverse sine of x over 2. Well, there's really no reason we can't put 2 up here. So we have inverse sine of 2 over 2, inverse sine of 1. If you go back up, look in your chart, where is sine 1? Right there. So 90 degrees would be our answer. And it says type an exact answer using pi as needed. So it doesn't want degrees, pi over 2. This is the question that was taken out of your homework. So remember that you're not going to have something like that. I put in the rules right here because the remainder of the problems will be dealing with the rules. Find the derivative of y equals inverse cosine 5x to the 9th. Remember that u, in this case, is 5x to the 9th. And if we think about u prime over, the formula is, let's see, square root of 1 minus u squared, and it was negative out here, okay? So if we're doing u prime would be 45x to the 8th, it's negative, square root of 1 minus that thing squared, which would be 25x to the 18th, because when you have x to the 9th squared, remember that you multiply, and that's x to the 18th. All right? Cosecant. Again, you have, this is u is 6x squared plus 1. So u prime would be 12x. So 12x is going on top. It is one of the negative ones, and it has absolute value of u times the square root of that squared minus 1. So we have a little bit of work to do here. When you square, put it over here, 6x squared plus 1 times 6x squared plus 1, you get 36x to the 4th plus 12x squared plus 1, foiling all that out. And then you had a minus 1. Well, those are going to cancel out. You now have this. What we need to recognize is that we could pull out an x squared. So if we do that, we separate the radicals into two different radicals because we want to simplify it. So we have 36x squared plus 12 times the square root of x squared. Square root of x squared, this guy right here, that's equal to x. So we have negative 12x over this times x. Those x's cancel out, and we're left with our final answer. So that's just some algebra that would be required on that one. Number 12, inverse cotan of the square root of 2t. You want to think, maybe rewrite it. That's what we usually say. We're going to rewrite 2t to the 1/2. Well, the derivative of that, I just wanted to do that over here. 1/2 comes in front, 2t to the negative 1/2. And so, and then times 2, because it's the chain rule. Well, 2 times 1/2 is 1, so that's all gone away, and we have 2t to the negative 1/2, or 1 over square root of 2t. So this is what we're going to put in our formula. So we have negative 1 over 1 plus that squared times the derivative of that. So we have negative 1 over, we know the derivative, it goes right here. It's on the bottom, times 1 plus 2t. Square root of 2t squared is 2t, so that's where that goes. Okay, so that's the final one there. All right, get rid of this. Inverse cosecant of e to the 3t. Well, you're going to have to take the derivative of this, because this is u. So that becomes e to the 3t times 3, because you're multiplying by the derivative of that. So that's 3e to the 3t. All right, so here's our formula. Negative 1 over absolute value of e to the 3t times the square root of that squared minus 1 times that derivative that we found right there. So let's put that on top. On the bottom we've got e to the 3t. Here we've got the square root of e to the 6t, because we squared it, minus 1. This and this cancel out. We are left with negative 3 over that. This one just wanted you to think about the restrictions on our inverse functions and your basic other functions. So inverse cotan 2, it says which could be defined and which are not. Could you have an angle that has a cotan of 2? That's the question you need to think. And yes, we can, because tan and cotan go on infinitely like this, so you could have one that has a cotan of the value of 2. So that would be that one. Second one is inverse cosine 2. Inverse cosine, well, we're going like that. Can you have an angle that has a cosine of 2? No, this is at 1, this is at negative 1. Whoops, not negative 2, negative 1. So you could not, that's not defined there. The last two questions are calculator, and I did it with probably more keystrokes than you need. You could just do, since secant is 1 over cosine, you could do inverse cosine, or second cosine would give you that on the calculator, parentheses 1 divided by whatever number you've got here, negative 9. You should get 1.68, and you should be in radians. You should be in radians, radian mode. The last one was the same idea. Cosecant is with sine, so you could do inverse sine of 1 divided by 8, and you should get, you'll get your answer. So that ought to get you going on the problems for 3.9.